Alright, so today we have a Gameboy Advance that I bought a long time ago, and it was horrendously corroded. So we are going to attempt to fix that today. So just to show some of the things I've done in the past before I gave up, because I just don't have the knowledge to fix it. But the switch here was horrendously corroded. The fuse that's coming from the battery to the switch was gone. It was eaten away by corrosion. The bumper buttons, or whatever they're called, were completely rusted. I don't know how long this thing was in a water ban, but it was outrageous. When I got it, I cleaned it all up, and I actually soaked the entire board in alcohol for a while, and then gave it a thorough cleaning. And then what I did to actually troubleshoot it was I wired from my positive post to my input pin on my switch, because those pads, I don't know, the other pads might be there as well, I'm not sure. And then I soldered some cables to my power supply on the positive and negative. And so where I left off was my indication on this was my LED would flash green when I applied power. So if I apply power, you can see it flashes green and then it goes off. So I found a schematic online and started tracing, in the schematic, the chain of events for everything. And so that circuit is fed by Q7 right here, which is according to the schematic, it's a MOSFET. So I started measuring voltage. If I measure here, that's either the source or the gate. I'm not exactly sure. Let me see. This one of them's supposed to be VCC. Okay, so this is the source. This pin right here, that's the source. And then the other pin is the gate, because the schematic shows the gate is tied to the source by a 1 mega ohm resistor. So that 1 mega ohm resistor is dropping the voltage on that. And so I've got source on I've got VCC or battery voltage essentially on my source. So I should, and this is a P-channel MOSFET, I'm getting 0.69 volts, which is not enough. And then that voltage is felt, that's called VDD3, whatever that means. I don't know what the DD means. I'm assuming the V is for voltage, but that VDD3 is felt, as far as I can tell, in two places. Here on the CPU, on pin 1, and it's felt into the circuit for your LEDs over here. So essentially you have DL2, which is your power on indicator, is tied to pin 1 it's pin 1 right here of U10. So things I've done, and I changed out Q7. I bought me a broken motherboard for parts, and I changed out Q7 in the same indication. I didn't think it was bad. I went over a lot of the solder joints just to make sure that they are in fact okay. So I'm kind of down to either U10 provides the path for current to flow, because this is again these two transistor chips. So you have the bases, and the emitter is in the center and it's tied to ground, and then the collector here is going to the cathode of DL2. And so in order for that LED to illuminate, this has to turn on. It has to, because you have to have current flow from emitter to collector to DL2 to complete that path. So I'm kind of down to maybe U10's bad, So yeah, that's kind of where I'm at with this. So maybe we should change out U10 with the one from this other board I have here. It's just weird though that it turns on for a second. So I mean, it kind of suggests that at least for an instant U10 is conducting, because that's the only place I can see for a path to complete for current for DL2. It has to go to ground. Maybe we should swap out U10 and see if that makes any type of difference at all. So let's go ahead and let's do that. So let's put a little flux around U10 here. Might have to get under the microscope to do this. So we got some solder on those pads, cleaned it up a little bit. So let's slide our chip into place. Actually, that's backwards. Let's see if we can use hot air to get that thing to set into place properly. Alright, I think that's in there. So we'll let that cool down for a second, then we'll clean it up and we'll give another test. Alright, I think it's cool enough now. Let me go ahead and clean this area up. I'm fairly certain this is a lost cause, but you know, what else do I gotta do, you know? It'd be cool to see it work though. It would be cool to see it work. Alright, so let's apply power and see what happens. Same thing. So the only other place I can find that DD3 goes is to this chip right here, which is the CPU. Since this thing was horrendously corroded, I think maybe I should just attempt to take that entire chip off, clean up all the pads, and then put that chip back on and see what happens, you know. I'm not sure I'm capable of pulling that chip off, but I will certainly give it a go. It's already broke, so how much more can you break it, you know? So I think my plan is going to be to apply solder, some leaded solder, and then use hot air to try to maybe heat it up and get it off. All right, so let's we're just going to heat it up and try to remove the chip without destroying anything. All right, we got it off. Yeah, I'm gonna have a devil of a time, I think, trying to get that solder off of there. That might have not been a good idea, you know. So I guess we can put this underneath the microscope and try to clean up the pads as best we can. See if there's any maybe damaged tracks or traces or whatever. Oh, there's a capacitor I knocked off. I'll have to make sure I put that back. Well, let's start cleaning up some of these. Just put some flux down. Alright, take a Q-tip, clean all of that up. Alright, now that it's clean, let's check for any type of damage. It should be obvious, you know. I am not seeing so far anything that would indicate damage to me. I'll tell you what, I got pretty lucky not knocking off but that one capacitor. Now, how are we going to fix this right here? I guess maybe some wick and braid. So let's see if we can get this done. I don't think that's going to be hard. Alright, so I think we need to look at that underneath the microscope. Not too bad, not too bad. Just gotta be careful not to bend these little pins. Alright, I think I got it off. Alright, so next step would be to put this back into place. I'm not exactly sure which direction that joker goes. Let's get another Q-tip and clean this up a little bit more. Yeah, I just hate to see things that have a possibility of being fixed, you know, not be fixed because of, you know, you just can't find the parts. I just hate it. Wish I was like the gentleman named Soren off of Electronic Repair School. I mean, that guy he's just an incredibly knowledgeable human being, you know. We are definitely going to have to get under the microscope to do this. Alright, so I removed that chip, the CPU. I put it back on, backwards, you know. So then I had to remove it again. But when I removed it the second time, I'm like, you know what? Let's see if I apply power, if that green LED will illuminate and stay on. So when I do so, look at that. The green LED illuminates and it stays on. So that tells me that that green LED is going off because of this processor. So I'm hoping that if I put it back on the correct way this time, it will, maybe it was a bad joint or something like that. So we'll see. Well, I put the processor back on, and then when I apply power, same thing happens. So I don't know if that's an indication that the processor's bad. That's certainly an indication that the processor has something to do with it. So I'm going to switch that processor out with one from that parts board I ordered. And I'm hoping that I'll get lucky. Maybe they didn't solder it on there properly or whatever. So I will be back. All right, so I put a new processor on there from that harvest board that I purchased. It's doing the exact same thing. I took off the RAM when I give it power. You know what? I think I might have figured it out, because earlier I decided I was going to, after I replaced the processor, and then I went ahead and took off that RAM slot, I cut it back on, and it was doing that same thing where it would green and then it would go back. So I went ahead and swapped over the U4 chip, you know, just as a thing to check, and now when I cut it on, it's staying green. This is the first time I saw that. So I'm going to go ahead and put that RAM back on there, and then we will give it a test. All right, we better give this thing a test. If I can figure out which way this ribbon cable goes in here. Uh-oh, I might have got some flux in that bad boy. You know what? I need to clean that port out. Yeah, I'm not sure if I don't know if this goes in here like this. That seems right. All right, so we about to apply power and see what happens. And that would be a big nothing happen. You know what I'm saying? But at least my green LED is illuminated. So, I'm thinking I should put my original processor back on there, because this processor here might be, I mean, like I said, I got it from a parts board. So, things that make you go, All right, let's think about this. I'll be back. Alright, so back with another update. So I put the original CPU back on the device, and now when I cut it on, the green LED still stays illuminated. We'll see if we can't pick up the sound. So I'm getting the Nintendo sound as it boots up. But when I install this thing I bought from eBay a long time ago for this, and I plug it in, it doesn't work. And then I don't even get any sound. So I don't get sound if I have the display connected. And I wonder if I could find the old display. It was just destroyed, but I'll have to look for it anyhow. So let me go try to do that, and I'll be back. Alright, so an update. So yesterday, I changed over the CPU, and that did nothing for me. So I went ahead, while I was down there, I went ahead and I changed out U4 with the one from my donor board. And in doing so, it started working. When I would cut it on, the green LED would remain illuminated, and I started getting sound you could hear the Nintendo booting up. But I wasn't getting any display. So I started checking, and I noticed that according to the schematic, this chip U4 is my voltage regulator, and it has essentially 3 volts coming in, and it produces 3 volts and 5 volts, and then that 5 volts is felt at this transformer right here. That transformer then gives you your 13 volts and your 15 volts for your display. So that's how I'm interpreting this. So essentially what I did was when I changed out U4, I inadvertently moved this resistor R33, and it wasn't making connection with the pad. And the 3 volts, I believe, comes in on this side, and then it is felt through this 4 ohm, 5 ohm resistor to this side, and then that's 3 volts is felt on pin 1 of U4. So essentially, I interrupted that. So the chip was not getting any voltage but I was still getting voltage somewhere, somehow, that would allow me to turn the Game Boy on. When I reconnected that resistor, now that I'm back to what it was doing, it gives me a flash of green light, and then it goes out. So I started measuring around. Well, in a last-ditch effort, I started measuring around this chip right here, and I noticed that I get 3 volts on pin 1, but I don't get any other voltages, and I'm supposed to get voltage on pins 2, 4, 8, 2, 4, 6, and 8. Those are supposed to be my drive voltages and my V out voltages for 5 and 3 volts, and I was not getting those. But I was getting 3 volts on pin 14 of U4. So I looked at pin 14 of U4, and that's my reset pin for U4. So I looked at the schematic, and U4, or the reset, originates at, but out of pin 125, you have the reset signal that goes over to EM7, and then EM7, that reset signal is felt to the reset via right here, located right here, and then when we flip that over and we go to that via, that's that via here. So I check continuity between EM7 and my reset via, and I have continuity. But when I flip the board, and I have continuity from that via to the other side of the board via, I have continuity there. But I don't have continuity from that via located, the via, this via here. I do not have continuity from that via to pin 14. And according to the schematic, it's a direct short. I should have continuity between those two. So now in a last ditch effort to see if I can't figure out, maybe reset, maybe the thing is booting up and reset voltage is applied, and so U4 never turns on. So I'm hoping that that's the issue, but we're about to find out. So I'm going to flip this over, and I have not cut it on yet, and I'm going to cut it on and see if my green light stays illuminated. It does. It does. It stays illuminated. Let me get under the microscope so you can see. It is illuminated now. And I'm drawing 92 milliamps, whereas before I only ever got 26 when I didn't have that. So now we're going to check voltages. So let me move all of this stuff out of the way. Let's cut that off for now. Well, first of all, what I'll do is I'll plug in my headphones and see if I get the Nintendo boot up sound. That would be amazing. So let's put our headphones on. I do not get any type of sound at all. Do I get something on the display? So let's plug in our display. So let's put power on. No, I'm not even getting boot up now. Alrighty, so I guess I'm gonna have to check for voltages underneath the microscope. So let's break out the multimeter, apply power. Now I'm not getting anything. Oh, there we go. So on pin 1, I'm getting 3.2 volts, which I'm supposed to. On pin 2, I should be getting voltage, and I'm not. Pin 4, I'm supposed to be getting voltage, and I'm not. And on that pin, I'm supposed to be getting voltage, and I'm not. But I'm at least getting on pin 8. Well, I've always gotten the V out, so I don't know. We got to figure this out. I will be back. All right, this is where I'm at. So when I apply power, it boots up. I'm not sure if it's producing sound or not. It is producing sound. So the next step is to see, well, first let me tell you how I got it to power up. So this whole time I had been focusing on, I had voltage coming into U4 located here. You're supposed to have 3 volts coming in from your battery. It goes through this resistor, and then it's fed on pin 1. And out of pin 1, or out of that chip, you're supposed to have 3 volts and 5 volts. And then that 5 volts is then goes to this transformer located here, and that's stepped up to your 13 volts to power your display. And so I wasn't getting the 5 volts, I wasn't getting 3 volts, so I changed the chip. I changed U4. And then I started getting 3 volts on my output, but I wasn't getting 5 volts or anything else. So I was thinking, I mean, it has to be that chip, right? Maybe if you've got voltage in, but you don't have any voltage out, and that's its whole purpose. So as a last-ditch effort, I went ahead and I changed this transformer. And lo and behold, I started getting my 13 volts and I started getting my 5 volts. So somehow, and I don't know how, but somehow if this transformer goes bad, you will not get 5 volts and 13 volts, whereas you were 5 volts and 3 volts out of this chip. And so it now boots up. It boots up, and so now we're going to try to test a game in it. But remember, I told you when I first got this device, I mean, everything was rusted. I mean, both buttons here were completely rusted to the point where I had to desolder them. And I ordered some new ones. I hope that I ordered some before, but they were wrong. So hopefully these will be right. But so now let's plug this back in, and we're going to test a game in this device and see if we can get Tetris to load. I know this game worked in a Game Boy I had. So, but you notice when I put it in there before, it kind of looks rusty. So I don't know if I'm going to be able to get this thing to ever load or not. I may have to change that cartridge out. So anyhow, so let's power it on. Let's see what happens with the game inserted. And nothing. So let's try. And I really hope I can get this to read games, because to be quite frank, I'm a little tired of working on this thing. So we're going to put some alcohol on a Q-tip, and then we're just going to put it in here. I don't know what a Game Boy is supposed to feel like. You know, obviously these things came out after I was a grown man with kids, but it feels kind of like it doesn't lock in there. It's not very tight. All right, let me show you where I've made it since the last clip. So this is a known good Game Boy Advance game. So when I put it in, this is what I get. The Nintendo logo comes up like it's going to work, and I get all excited, and then nothing happens. So I don't know. This thing has whooped me pretty good. I think I've changed out the cartridge with the known good cartridge. Not working. I've touched up every single leg of the CPU and RAM, and they're all good. They're all making connectivity. I've checked for continuity between the cartridge and the CPU, and all of the continuity is as it's supposed to be. So the last thing that I'm going to do is I am going to take the RAM off of this and put the RAM from my donor board that I have, and I don't know if that RAM is good, and see what changes I get when I do that. And if that doesn't work, or if I get if I get some sort of change, I may take the RAM off of the known good Game Boy that I fixed previously, just to try. But I think that's it. I'm not fiddling with this thing anymore. I'm going to have to admit defeat. I hate it, but this thing is killing me. So let me do that, and I will show you my findings. Well, I changed the RAM with the RAM from the donor board, and the console wouldn't even boot. So then I took the RAM from the known good board that is working, and it did the same thing. And then I took the CPU back off just to ohm one more time to check for continuity for some of the pads where they run underneath the chip. And all of those were good. So the only thing I can conclude is that the CPU is in fact bad. So I'm convinced enough to where I'm not going to lose sleep. I'm not going to keep trying. I think that's the problem. And I'm just chasing my tail. I think this thing was, the corrosion was too much for it because it had a lot. I touched every component at least once, I'm sure, with a soldering iron just to touch up everything. But anyways, thanks for watching. Hopefully I can put the other one back together and hopefully it'll still work, Hopefully I haven't damaged anything. Anyhow,